going to talk about is Uranus. Uranus has a semi-major axis of 19.2 AUs. Hey, guess what? That's almost exactly double Saturn. So it's kind of easy. Once you get outside, get to Jupiter. Jupiter's at 5. You double that, you get to 10. That's Saturn. You double that again, you get to 20. That's Uranus. So it works pretty well to just kind of remember about how far they are. Well, remember, if you're at 20 times further away, how much light or energy you get from the sun goes by the square of that number. Well, 20 squared is 400. And so it's getting 1/400th as much light as the Earth is. So it's getting really cold out here in the outer parts of the solar system. Uranus has a period, a revolution period, of 84 years. So you have to live to be 84 just to make one Uranus year. The mass is 15 times the mass of the Earth. And it has a diameter of 50,800 kilometers. Remember, the Earth was 12,000, so this is about 4 times bigger than the Earth is. Density is 1.3 grams per cubic centimeter, which is about typical of the Jovian planets, okay? About what Jupiter was at. And its rotation period is 17 hours. Okay. All right, a couple of things that make Uranus unique. But first of all, before we talk about that, let's talk about how it was discovered. Because up until Uranus, all the other planets, there was no discovery. You could just go out and look at them with your naked eye. So yeah, all the ancient people, everybody knew about the other planets, right? Up through Saturn, you can just go see it. But Uranus had to be discovered because it's too faint to be seen without a telescope. So they had to find it once you had telescopes. So remember, telescopes were invented about 1610, right? 1610, 1611 was 1609, 1610, right in there. So people started getting bigger and better telescopes, but it still took a while to actually discover much. There was a guy named William Herschel and William Herschel and his sister Caroline. He was fairly well-to-do British guy, and he built the biggest telescope in the world at the time. It had a mirror about this big, okay, in the 1700s. All right, this is late 1700s. In fact, March 13th, 1781 was the day he discovered Uranus. Well, we think. Nowadays, looking at historical records, he may not have been the one that discovered it. It may have been his sister Caroline. What they did is they had several different telescopes. He was fairly well off, he was really into astronomy. And so they built these telescopes, and they were very long telescopes made with metal mirror instead of glass like we use nowadays. And you'd have to go up ladders and look through it, and it was hard to adjust and change positions. Mostly you would kind of put it at one position in the sky, and you would just kind of let the sky rotate through, and you would just watch what comes through. And they started cataloging all kinds of things. In fact, they created a whole catalog, what's called the New Galactic Catalog. It found all kinds of clusters and nebula and all kinds of stuff. And that catalog's been revised, and we still use it nowadays, but it started with the Herschels. But they would take turns looking through the telescope trying to find different things. And all of a sudden, what came into view was that all stars just appear as dots. No matter how much you magnify a star, it is still just a tiny dot. Okay? But then they saw a disk. They saw a blue disk. And they realized, oh, if it's a disk, then it's not a star. Now, they had to watch it for a little while to see if it moved. And once it saw that it moved, they realized it was a planet. Okay? And then by how much it's moving, how fast it's moving, essentially you just watch it move across the sky and say, oh, in so many days it will move this far. that can tell you how far away it is, and then you can start to calculate things like, well, if it's that far away, it's reflecting that much light, you can calculate how big it is, so on. And they found the planet. Now, originally they were going to call it Planet Herschel. It was the first discovered planet. But then they decided, no, we want to keep going with the Roman god themes, and that's why it ended up becoming Uranus. Okay? All right, and we think that in their journals, they would take turns looking through it. Caroline may have been the one that was actually observing that night of the first discovery of this object. And so, but you got to remember, this is 1700s, 18th century, even through the 1800s in England, women weren't given credit for anything, which was really wrong. And so, all the textbooks you look up until about the 1970s or 80s all say that William Herschel discovered it. Now, if you look at newer ones, they realize that they're giving credit, and usually they give credit to both. We can say that both William and Caroline discovered it, because we give her the due credit she deserved when the discovery occurred. All right, one of the interesting things about Uranus is it has a tilt of 98 degrees. Like 98 degrees, that's really weird. Yeah, that is weird. So here's the Sun. Here's Uranus going around on its 84-year orbit. But if we put Uranus over here, what that really means is that sometimes its north pole is pointing pretty much directly at the Sun. Then over here, it would point perpendicular, and then over here, the south pole points at the Sun. So, you know, we're used to thinking of the axis like this, Sun being over here, but now it's like this. And so it goes around like this, and that pole is pointing pretty close to the Sun. And it depends on where it is in its 84 years, what you see. So if you lived on the north pole of Uranus, from here, right when you got to this point, if you're on the north pole, the Sun would start to rise. And then the Sun would be in the sky for half of that, or for 42 years. So for 42 years, the Sun would never set if you lived on the north pole of Uranus. And then you'd have 42 years of darkness. It's kind of like on the Earth, if you lived on the north pole of the Earth, you have 6 months of daylight and then 6 months of darkness. On Uranus, it would just be 42 years of that. Kind of crazy. It would just go around your sky in these circles, but it would never set. Okay? Very weird. We think it was actually just formed that way. Remember, all the planets are formed in this spinning cloud of dust. All right? In fact, we know it had to be formed like that. It wasn't like Venus that got hit and changed its rotation. In this case, you couldn't hit it and knock it over, and you couldn't hit it and knock it over and make all the moons, because all the moons orbited on near its equatorial plane too. And so you can't tilt the planet and the moons and everything simultaneously. But you do get these back eddy currents. It's kind of like water flowing, right? The water will all be flowing, but then there'll be ripples and there'll be currents where it spins off in slightly different directions. That's what we think created this tilt on this, is that as the cloud was spinning around, there was kind of this eddy that formed that was spinning slightly in a different orientation. That's the one that Uranus formed out of. Okay? You can make that happen using computer simulations. That's our best guess right now. Now when Voyager 2 went by here, because Voyager 1 didn't, and it went to Jupiter and Saturn, Voyager 2 flew by Uranus, it looked like this. And they said, wow, that is the most boring planet ever. It is just a blue cloud. What is it made of? Well, guess what? It's made of the same thing that Jupiter and Saturn are. The clouds, or this cloudy ice cloud layer, is mostly methane. But if you get methane and ammonia, you get really, really cold, you get this bluish color. Okay? Temperature on the surface is very, very cold. You're down to about 70 degrees Kelvin. So that's very, very cold. And that gives us this blue color. We don't see the differential rotation. We don't see the cloud bands. Well, we found out, we thought that this was, wow, that's the way it looks. We realized when Voyager 2 flew by, because Voyager 2 is going like 40,000 miles an hour, it took it about 2 days and it whipped right by. That it just happened to be on a very nice, smooth day. You can see a little bit of stuff down here. You probably can't see that on the video, but if you look at it close. But if we take a picture with the Hubble Space Telescope, we find, hey, it does have some, I mean, this is as good as it gets from there. It does have some cloud bands, and it has some storms. It just, when Voyager 2 happened to fly by there, it was a very smooth day. Okay? It just happened to be not much going on that day. Notice this is the North Pole is actually up here, right here, kind of pointing towards the Earth. That just happened to be where it was in its orbit at that time. It's changing position as it rotates around the sun. All right, when we look at Uranus, we also realize it had rings. The cool thing about that is Uranus's rings were discovered before we even saw them. Like, how do you discover rings before you see them? Well, here was Uranus, and Uranus is going to pass in front of, or what we say, occult a star. Remember we talked about occultation, when something passes in front of something else. And so astronomers were watching this, and they were watching the brightness of the star. They're going to watch this brightness of the star as Uranus passed in front. And they see the star, and it got fainter, and it got fainter before Uranus even got there, and then Uranus blocked it out completely. And then it was the same thing on the other side. So they realized, oh, there must be something out here. Uranus was actually pointing almost directly at us at the time, so it looked kind of like a bullseye. And so they realized that these were rings. And so they watched Uranus do this in front of many stars, and they knew the rings existed, but it wasn't until Voyager 2 got to Uranus that they actually saw the rings. This is still, again, a Hubble Space Telescope picture. Notice the rings here. The North Pole is sticking out like this, so it's very different than Saturn. And Saturn only has about a 30-degree tilt. This is that 98-degree tilt. And the rings are very narrow, thin rings. Very dark, very hard to see. What's that tell you? That tells us the rings are very old, and that these thin rings, the only way they can exist